Hey everyone! Welcome back to ZoomInData. And this is episode 17 of our KQL Concepts Deep Dive series. Today we are exploring grouping mechanics, how the by clause really works, and the dangerous cardinality explosion risks. We are keeping everything pure concepts and interview focused. If you missed episode 16 on null semantics, it's a good one to review. Let's get started. Here is our roadmap for today. The by clause groups rows by unique combinations of values. Grouping creates one output row per unique group key. Cardinality equals the number of unique group keys. High cardinality equals explosion. High cardinality grouping can cause memory pressure and slow queries. KQL optimizes grouping using hash aggregation and spill to disk. Understanding cardinality helps prevent out-of-memory failures. Let's dive into the mechanics. Let's look at how grouping works under the hood. The by clause builds a hash table of unique key combinations. Each unique key gets one bucket in memory. Aggregations like sum and count are computed per bucket. Hash collisions are handled with chaining or open addressing. When memory is full, KQL spills to disk, slower but safe. Final output has one row per unique group key. This hash-based approach is fast for low to medium cardinality but becomes expensive as uniqueness grows. Now the big risk, cardinality explosion. Cardinality is the count of distinct group by key combinations. Low cardinality, like grouping by status with only success and failure, creates just a few buckets, fast and low memory. High cardinality, like grouping by user ID plus timestamp down to the second, can create millions or billions of unique groups. That's explosion. Too many buckets lead to memory exhaustion or heavy disk spill. Common triggers are grouping by high cardinality columns like IDs, timestamps, or raw strings. This is one of the top causes of query failures in production. Take a quick look at this diagram. It shows the cardinal difference between safe and dangerous grouping in KQL. On the left, low cardinality. Something simple like status with just two values, success and failure. See the small, tidy hash table icon. Only a couple of buckets in memory, super fast, low resource use, green check all the way. On the right, high cardinality, grouping by something explosive like user ID plus exact timestamp. Watch the hash table literally explode. Millions of unique combinations mean millions of buckets. Red warning icon lights up, memory fills up fast, and you see those spill arrows dumping overflow to disk. Slow, painful, and can crash the query. The middle divider says it all. Cardinality explosion risk. The more unique group keys you create, the worse it gets. This is why binning timestamps or filtering early before group by is non-negotiable in production. Keep cardinality low, or your queries will pay the price. How do we mitigate cardinality risks? Bin timestamps before grouping. Like bin, timestamp, 1H, turns millions of seconds into hundreds of hours. Use low cardinality keys or pre-aggregate in materialized views. Apply filters early to reduce rows before the group by. Use approximate functions like dcount or approximately _count distinct when exact count isn't needed on high cardinality data. And always monitor query diagnostics for high group count warnings. These simple habits prevent most explosion disasters. A few edge cases worth knowing. All null values in a group by column form exactly one group. Not scattered, not ignored. One single null group appears in output. With multiple by columns, null in any column still collapses into one combined null group. Grouping by dynamic or array types can explode cardinality very quickly because of nested uniqueness. And if the input is empty, you get no groups at all, including no null group. These behaviors are consistent but can surprise people coming from other query languages. Check out these 3 quick scenarios. They show exactly how KQL handles nulls when you group by. First one, single column with all nulls. All those null rows collapse into exactly one null group, not scattered, not ignored, just one tidy group. See the single group icon. One null group. Second scenario, multi-column grouping. One column has null, the other has values. Even with mixed data, all rows that have null anywhere still end up in one combined null group. Null in any key makes the whole combination null, and they all merge together. Combined null icon here. Third case, completely empty input. 0 rows go in, so you get 0 groups. No null group, no nothing. Just an empty result. No groups icon. These rules are super consistent, but they surprise people. Remember, nulls always collect into one group when grouping, and empty input means no output rows at all. Nail this, and your group by logic stays rock solid. Why does this topic matter in interviews? Interviewers ask about grouping performance and pitfalls. Common questions include, what causes cardinality explosion? And, how does group by handle nulls? Understanding hash aggregation shows deep engine knowledge. This topic is critical for production query tuning and debugging. Explaining mitigation strategies demonstrates practical expertise. Nail this, and you show you can write queries that scale without crashing clusters. To wrap up, the by clause creates one output row per unique key combination. Cardinality equals the number of unique groups. High cardinality equals explosion risk. Explosion causes memory pressure and disk spill. Mitigate with binning, early filtering, and approximate functions. Nulls form exactly one group. Empty input equals no groups. Master these mechanics, and you'll avoid one of the most common causes of slow or failing queries in KQL. That's episode 17 done. Thanks for spending time with me on ZoomInData. Next in episode 18, Aggregation Functions Philosophy, we will explore exact versus approximate aggregations, count versus decount, and when to choose each. Homework to lock this in. Explain to someone or out loud, what is cardinality explosion and how do you prevent it? Think of a query where high cardinality would cause problems. Answer this one. How does group by handle null values? If this helped, like the video, share it with anyone prepping for Azure interviews, subscribe for episode 18, and drop a comment with your biggest takeaway today. Thank you so much for watching ZoomInData. See you next time. Keep zooming in on those concepts. Bye for now.